Okay, we can combine a real number with an imaginary number and get a different type of number that we call a complex number. And a complex number has the form of a plus bi. And in this situation, a is a real number, b is a real number, and it's really a coefficient since it's multiplied by I. And I is imaginary. And that's the form that a complex number will take. And it's an actual number, just like 3 is a number or pi is a number. This weird combination is an actual number and can be treated like a number. And if it can be treated like a number, then we should be able to do operations on it. For example, we should be able to do adding and subtracting. Adding and subtracting. So if we add two complex numbers, a plus bi plus c plus di, where d and c and a and b are all real portions of this complex number, well, then what you need to do is you need to add the real components, a and c, and then add the imaginary components, b plus d. Of course, this is all multiplied by I. So let's do an example. 5 plus 3i plus 2 minus 2i. All right, well, as I said before, we first add the real components, 5 plus 2, and then we add to this the imaginary components, 3 minus 2i. So this equals, simplify this, 7. 3 minus 2 is 1, minus 1i, or 7 minus I. So I'm going to stop doing this 1i and just show this as 7 minus I from now on. Now, subtraction can also be done, and it can be handled in the same way. But what I like to do in these subtraction problems is distribute the minus sign through here. So this is minus 3, and then minus times minus 2 is a positive 2i. So now I am doing these operations, and whenever you do operations with mixed real and imaginary numbers, you do the real numbers first. Well, you don't do it first, but you do them separately. 2 minus 3 is minus 1, and then 3i plus 2i is plus 5i. So again, both of these are numbers. They are complex numbers. Okay, so let's do multiplication. So let's multiply 3 plus 2i times 2 minus I. Well, we can handle this the same way we handle multiplication of any binomial. We would first take this 3 multiplied by the 2, and then take the 3 multiplied by the I, like so. Then we take the 2i multiplied by the 2, and then the 2i and multiply by the I, and end up with this. Okay, let's reduce all these. So we've got 6, and then 3 times minus I is minus 3i, and plus 4i, and then plus 2. Actually, it's not plus, it's a minus, because there's a negative I here. So this is minus 2, and then it's I times minus I is minus I squared. So minus 2I squared. So the I is squared here. Okay. So we've got 6 minus 3i plus 4i is just plus I. There's 1 left over. And then minus 2I squared. Well, I squared, I times I is minus 1. So this turns into a real number over here. So this is 6 plus 2 is 8 plus I. And that's our result. Okay. So suppose it comes in a different form. Suppose our multiplication looks like this. We can solve this problem. Let's first convert this to 6 minus, so the square root of minus 4 is the square root of minus 1 times 4. And then all of this is still multiplied by the square root of 9. And the square root of 9 is the square root of minus 1 times 9. Well, this equals 6 minus, so this is the square root of 4 times the square root of minus 1, or the square root of 4, the principal root is 2, times the square root of minus 1 is I. Square root of minus 1 is I. And then, of course, this quantity is multiplied by, so this is the same thing as the square root of 9 times this quantity square root of minus 1. So square root of 9, the principal value is 3. So this is times 3. And the square root of 1 is I. Okay, so now at this point, we have to distribute this through. We have to multiply this by this and this by this. So let's do this one. We've got 18i. 3i times 6 is 18. And then minus 2i times 3i is minus 6. And it's an I times an I there, so you got to keep track of that. I squared. So 18i minus 6i squared. Well, this is the same thing as 18i minus 6 times I is minus 1. So we've got minus 6 times minus 1 is positive 6. So this is 6 plus 18i.